and welcome to the third and final installment of our educational video series on investigating suspicious scheduled task activity in Defender for Endpoint. In the first part of this series, we ran an atomic red team test. We generated a variety of alerts, and we showed you how you can investigate and how you can triage those alerts. Then in the second part of this video series, we explored the various response actions that are available in Defender for Endpoint that you can act on based on the alerts that you received. Now, in this part of the video series, we are going to pivot into the advanced hunting console. As Joe was saying at the end of the last video, when you're in that alert device timeline view, you can go ahead and you can generate a dynamic Kusto query. And that's exactly where we're going to start off here. From there, we'll create somewhat simpler Kusto queries that are sort of looking for more broad sets of activity. And then we'll pare those down to really home in on the telemetry that we are looking for. Now, Red Canary uses the Advanced Hunting Console's API to draw raw telemetry out of Defender for Endpoint so that it can be parsed by our engine and by our detection analytics. So we're going to pivot into Red Canary at the end of the video and show you the added value, right? The added defense and depth you can get by relying on our detection engineering expertise and our analytical expertise. But without any more introduction, let's go and learn more about the Advanced Hunting Console.
So this is actually going to pivot us directly into the advanced hunting section of Defender for Endpoint, which uses kind of its own data pool of all the information that happens on that machine. So this actually generates a relatively advanced piece of KQL that is going to query that machine for related process events that occurred within that particular time period. You can see here, and sort them by relevance, etc. Now this is pretty cool, but it's also pretty advanced. What we want to do is we want to take some of this information and we want to kind of like just break it down and make it a little bit more simple, make it a little bit more digestible. So we're actually going to create our own query here that contains similar data, but perhaps displays it in a little bit easier to understand format. So let's do something more like this. Let's delete this information that we have here, and we'll start with something really simple. So what we're doing here is we're just going to list over here on the schema. You can see we have a number of pieces of information available to us. One of us is device process events. So think of these as tables in this kind of database, if you will. And we're able to come in here using KQL and just list out and query a lot of this information in real time. So in this case, we're looking for the particular device name of interest where we have scheduled tasks running on the command line. And so it produces a number of pretty interesting things that happen here. And we can go through here and investigate these and determine, and this happens to be one of the malicious ones, whether or not these are malicious or not. And, that's actually a pretty cool thing. And so you might think to yourself, like, okay, now that I have this power to do this, what could I do? Well, the number one thing, obviously, that everybody wants to do is to do things at scale. So rather than to specify a host name, we can actually just search the environment and look for all of those scheduled tasks across the command line, but for the entire environment. Now, the challenge with this ends up being, without applying those indicators of compromise, scheduled tasks in and of itself, it's not inherently malicious. So while we may find some evidence of malicious activity, we may find some evidence of non-malicious activity. We might come in here and start looking around and find like, okay, like this looks like it's probably just the office updater task, right? So when we want to then, think about optimization of the query and pivoting through the data set, we have to do something that's going to just kind of guarantee that we're finding more useful information. And the way that we do that here is by including that temp folder that's inside of our indicator of compromise, because we knew that, based on that command line string, that temp was included as part of the location for that. Now, when we run that, now we're going to get just the instances of task scheduler that contain temp on the command line across the environment. What we can find is that malicious activity is only executed on a handful of machines inside of our environment for test purposes. The reason this is so relevant, if we think about it, is that extracting those IOCs and applying them to our queries is really important, because if you have something like ransomware or something else that is leveraging launching from a particular location, has a particular file name, file path, you're able to really start to reduce the amount of noise that you have in your queries while you're querying the entire environment for a particular thing. Brian, would you be able to just walk us through this on the Red Canary portal to just show us about how we take some of the same information out of advanced hunting and apply some of our own kind of analytics to it and help display it in a useful way?
Thank you, Joe. So Red Canary actually leverages the API of the Advanced Hunting Console to stream that raw telemetry that we were just searching through out of Defender for Endpoint and into our own detection engine, where that telemetry then gets parsed against our library of thousands of detection analytics to look for additional activity or to provide additional detection coverage. So by using a solution like Red Canary on top of Defender for Endpoint, you're getting more redundancy and more defense in depth. So we've done 2 trios of videos, right? Like this is the investigation of a scheduled task test. In the previous video, we did an investigation into some masquerading activity. All of the confirmed threat detections associated with both of those tests exist on this timeline. So if you watched that last trio of videos, you'll remember that I described sort of this red part at the top is kind of like the headline, the highest level information. Then you sort of got this second piece here, which is more like a subheader. And both of these things in this context just describe that, we found this suspicious activity. It is related to Atomic Red Team. As you scroll down, we've got this observed techniques section. The defense evasion stuff over here is related to the first test we did for the first trio of videos that's related to some funny business that we did with PowerShell and Notepad.exe. What we're interested right now is this scheduled task activity that's listed in the privilege escalation, execution, and persistence sections. So across those 3 Mitre ATT&CK Tactics, there still is only one detection analytic that was used to catch this. And so these all caps abbreviated sort of short names here, these are the titles for our detection analytics. In this case, the test that we ran, it triggered a detector that identifies when the scheduled task includes a reference to command in the command line. So I will show you exactly what that looks like below because we will have access to that command line data. So as you scroll down, right, we've got this timeline that was built by our detection engineering team. All of this activity up here is related to those first tests. So we ran those PowerShell tests first for the previous video series. That's where our detection engineers believe that the threat actually occurred. As we scroll down more, you can see, okay, here we go. This process spawned by command.exe. So this is a scheduled task being spawned by command.exe. And the scheduled task includes the exact contents of the test that we ran. So we'll highlight that here. And if you were to go back into the first part of this video series where I showed you the Atomic Red Team test we ran, you would note that this command line is verbatim with the test that we ran. And then you can see down here, this annotation points out that the command creates a scheduled task named command test task, and that it executes this command right here. And again, here is that current date text file that's in the temp directory that Joe Savini went ahead and downloaded in the previous video in this video series. So that is basically all we have for this video series. We hope that you found it useful. We are probably going to do another trio of videos looking at a different kind of activity because we still feel like there are some analytical features of Defender for Endpoint that we haven't totally showcased yet. Again, if you guys would like us to show you something in particular from Defender for Endpoint, if there is a technique that you think would be particularly interesting for us to investigate, you can hit us up on Twitter or contact us in some other way, and we will try to incorporate that into this video series. So that's all we've got for now. Thank you so much for watching. And again, we hope you found this useful. And of course, thanks to Joe Savini for being our tour guide through Defender for Endpoint.